So this is a quick tutorial about how to approach 12.74. So you guys have something about a solution that contains a mixture of pentane and hexane at room temperature, which we can assume is 25 degrees Celsius. You can always assume room temperature is 25 degrees Celsius. Gives us a couple of pressures, and it gives us the pressure of the mixture, and then the pressure of pentane and the pressure of hexane under normal conditions. So it asks us what the mole fraction of hexane is. So a couple of things you need to know to approach this problem, and I'm just going to kind of cut to here really quick. Anything from methane to octane, which is this is CH4 to, well, there's 8 carbons that are fully saturated with hydrogens. Like, the octane's the gas for your car, and we know that that's volatile because we burn it in order to run our car. So anything between methane and octane is definitely going to be volatile. So just kind of give you guys a heads up. Like, it is volatile a little heavier than that, but we're not going to worry about that right now. Okay, so anyway, back to this. So basically all we have is a mixture of two volatile things in a solution. So I wrote down what we know. We know the total pressure is 263 torr in my case. The pressure of our pentane was 425 torr, and the pressure of our hexane under normal conditions is 151 torr. So these are two standard pressures, and this is the total pressure of a mixture. So what we know is we actually know Raoult's law, which is the pressure of A times the mole fraction of A. The pressure of A under some kind of condition where there's just a fraction of the mixture. Like, this is that pressure, and it's proportional to the mole fraction of A in whatever it is times the pressure of A. But if we have a mole fraction, we know that there's other stuff in it. So you can actually expand this, and this should be on your note card, by the way. Your total pressure is equal to the mole fraction of the standard pressure of A plus the mole fraction of B times the standard pressure of B. So this is actually what we're going to use to solve. And you can make like hexane or pentane either A or B. But to pull this off, the fractions, if you add up all the fractions and stuff that are in there, and the only things it mentions are hexane and pentane, if there's nothing else in there, you can assume that these two, like the sum of the fractions, are going to equal 1. So, like, you can either solve for either the mole fraction of A or the mole fraction of B in terms of each other. So it's just going to be the mole fraction of A is equal to 1 minus the mole fraction of B, or you can make it the mole fraction of B is equal to 1 minus the mole fraction of A. So that's just basic algebra. Anyway, so you'll just set this up, and you'll do, like, whichever mole fraction you decide hexane is, that's what you want to solve in terms for. So, like, if you want to solve for the mole fraction of A, you're going to have to set it up to where you solve for mole fraction of B in terms of B. So, like, this one, your mole fraction of A, I would actually make that the hexane mole fraction, because that's just easier for me because I already solved that one. And then this is the mole fraction of pentane times the standard pressure of pentane. But this one's the mole fraction of hexane times the pressure of hexane. But you guys can set this up however you want. So anyway, like, when I distributed this through, it came out to the mole fraction of A times the pressure standard of A times the pressure standard of B plus the pressure standard of B times the mole fraction of A. And then you just use algebra to solve for the mole fraction of A. So you guys can do that, and that'll be set equal to the total pressure, so you guys can just do the algebra. Okay, anyway, I hope you guys have a good one.